Okay, these are the parts of Chapter 3 which we didn't really cover in last week's lecture, so I want to go over them now. First, I have to get the SocialViz package in Tidyverse and build the county's data frame, as in the previous set of exercises. So here we are, everything including filtering the county so that it has only populations which are greater than 0. So I want to reduce the number of variables in counties and also add a continuous variable called density. So let's do that. So counties is counties, and then mutate. Density is pop/land area. In other words, population per square mile. And I'm only going to keep FIPS, name, census, region, state, pop, land area, and density. Okay. I want to make that long and narrow by collapsing pop, density, and land area into a variable called measure. So you've seen some examples of this. Hopefully you may try to do this on your own. If you feel comfortable trying to do this on your own, please pause the video and try it before you go on. Okay, let's take a look at the way I did it. Call it counties long. It's counties, and then pivot longer. The columns that I want are everything beginning with pop and ending with density. And we'll call the names to measure and the values to value. And this is what it looks like. You can see that you've got Autauga County, which is in the Census Region South of state Alabama. It has 3 new rows, one for pop, one for land area, and one for density, because they are all different values of the variable measure. And this is before this was, these 3 were in 1 row. Now they're in 3 rows. Okay. So now I can use Facet Under Grid to show how the regions compare for these measures. Okay, please try that on your own before you look at my solution. Okay, let's look at my solution. So the thing that goes on the x-axis is going to be the value in every case. And I want a density in a rug. And I want to scale x according to log 10. And then facet grid, census region tilde measure, and scales equal free x. Because these things, density, land area, and population, all have very different ranges of x values. Okay, so you can see all the detail on how the regions differ in all of these measures. A lot to look at here, a lot to comment on. Here's kind of a funny one. The land area for the Midwest looks like very different from the land areas for the other areas. Okay. So that's a bit busy and possibly hard to read. So I want to use filter to compare just the West and the Northeast for land area. So we're down to 2 regions and 1 variable. But otherwise the basic same setup. Okay, please try to do that on your own. Pause the tape and come back and start the tape again when you're ready to look at my solution. Okay, let's look at my solution. I didn't create a new data frame. I just stuck the filter command in between counties underscore long and the ggplot commands. So pipe here instead of piping directly to ggplot, pipe through the filter. And now you can see the land area comparison for the Northeast and the West. And you can see that the largest land area for the Northeast is here. And there's still a lot of land areas for counties in the West, which are much greater than that. You can see the West has 1 whopper of a land area. more than 10 times as big as anything in the Northeast. So I want to use Summarize to compare the land areas of counties in the region and capture min, median, and max values. So I think you know how to do that, so please give it a try. And after you're done, take a look at my solution. Okay, let's look at my solution. So I filter the measure equal to land area, then group by census region, and summarize min, median, and max. And then after you're done with the summarize, you always want to ungroup. Then I arrange it according to median value. And then I do the ggplot. Y is census region for every thing. But there are 3 different geom underscore points. In one of them, the X attribute is linked to minimum. In another one, the X attribute is linked to median. And another one, the X attribute is linked to max. And then I gave it a title. Okay, let's look at it. And as you can see, it's somewhat unsatisfactory. And the problem is you got this huge, whopping land area, one county in the west, just dominates everything. And it forces compression of all the other values into a tiny area where you can't even see the difference here. Okay. It looks like the minimum and the median are basically the same because of that, the compression effect coming from the one outlying value. Well, we know how to fix that. Use a log scale on the x-axis. I think you know how to do that by now, so please apply the log scale on the x-axis and then come back. Okay. Looks the same, just that we added down here at the very last thing, scale underscore x is log 10. You may have thought that you'd have to put that up here someplace, but you don't. As long as you haven't completed your specifications in ggplot, you can add any layer you want anywhere you want. It winds up being the same. Okay, now we're going to try joining. And I got some data on the uninsured rate by county from this source. And there's a whole lot of data that came back with this characteristics data frame, so I just selected the things that I wanted, which is the county, really the FIPS code, and the percent uninsured in 2010, and the county name and the state name. So all these things exist in the other data frame, but they have different names. So here's a look at the structure of the uninsured rate. There's your county names, and there's your state names, and there's the percent uninsured. So I want to see the distribution of county uninsured rates by census region. How do I do that? Please give it a try, then come back. So I'm going to get a regions table. I'm going to trim the county frames down to just the identifying variables. So regions equals counties, and then select the FIPS code, the census region, the state, and the name. And I use head to look at what that looks like. And there we are, the FIPS code, the census region, the state, and the name. Now you realize that you had all 3 of these, the identifying information, FIPS, and the county name, and the state name, in the uninsured rate data, but it was different. So to join them, you have to have this because the FIPS code had different names in the two different files. We're joining them by FIPS code. So by equals C of FIPS equal county. And then I look at the head of join, and I've got this, and now I have all the data combined in one table. You notice that this Alabama, that's a wrapping around of the name. This is actually, the format here is just a little bit too, yeah, okay, I changed it. Did a command minus so I can see what's happening. From the one table I had AL, the code for Alabama, and from the other table I had the name Alabama spelled out. In one table it says Autauga County, and in the other table it said Autauga. But the point, I've got all the information now with the uninsured rate. Okay, let's take a look at it. So we're going to use facet wrap to see the distribution of the uninsured rate by region. So please do that. I think you know enough to do it. Okay. Let's make that a little bit bigger. So X is the percent uninsured. And then I want a geom underscore density and a geom underscore rug. And then I want a facet wrap so that I see census region. So I don't just have the density of the percent uninsured, I have it by census region. You can see that the South has very the South, here's the South. The South and the West both have kind of high uninsured rates. The Northeast peaks at a very low uninsured rate, and the Midwest is kind of somewhat intermediate. Okay, that's the end of pivot, join, and summarize.